So yes, hello dear students. I am Vinayak, and first of all, thank you for visiting my YouTube channel. So in this class, let us learn about the Heron's formula. That is chapter number 8 of 9th standard. Okay. So Heron's formula is basically a formula to find out the area of the triangle. But already we know one basic formula to find out the area of the triangle, that is half into base into height. So, but in this class we are going to learn one more formula to find out the area of the triangle. Okay. Before proceeding to Heron's formula, we need to learn some of the basic concepts, or we need to learn some of the basics such as perimeter, semi-perimeter and area. Okay. So in order to begin with the perimeter, let us consider a rectangle here. Rectangle A, B, C and D. And here the sides I have taken as 10 meter and here also 10 meter, because already you know that opposite sides in rectangle will be equal. So here also 10 meter, here also 10 meter. Likewise, if BD is 8 meter, then AC will also be 8 meter. So to find out the perimeter, we need to add uh, all the lengths of the sides of rectangle. Means we need to add these all sides. Means perimeter P will be equal to side AB plus side BD plus side DC plus side AC. So I have substituted the values here. Means AB is 10 meter, BD is 8 meter, DC is 10 meter, and likewise AC is also 8 meter. So 10 plus 10, 20, and 8 plus 8 is 16. So 20 plus 16 is 36 meter. So this is how we find the perimeter. Means perimeter is nothing but this outline. We should all the sides so that we will get perimeter. And now let us move on to the next basic concept, that is semi-perimeter. So here the word semi itself means half. Okay, so semi-perimeter means half of perimeter. So already we find the value of perimeter, that as 36 meter. So semi-perimeter means half of perimeter, that is 36 divided by 2. Why 2? Because if we divide any number by 2, we get its half value. So 36 divided by 2 is equal to 80 meter. So this 18 meter is semi-perimeter. Okay, if we divide perimeter into its half, we get the value of semi-perimeter. I hope it is clear. Let us move on to the next basic concept, that is area. So again, in order to explain area, I will take this rectangle as example. Okay, this whole inside space is called as this whole. If we measure this whole inside space or place, it will be come out as area. Means this whole space, inside space, is called as area. Again, as you know, area, the formula to find out the area of rectangle is L into B, that is length into breadth. So again I have substituted the values here, that is 10 meter into 8 meter, that is 80. 10 into 8 is 80 meters square. Likewise, the formula to find out the area of the rectangle is, that is area of the rectangle is, area of a triangle is half into base into height. Okay. Okay, I hope it is clear till now. Let us move on to some more basic concepts such as units of measurements. Okay, as you here, unit of measurement for area of any plane figure is square meter or centimeter square. Okay, it is denoted as meter square or centimeter square. Likewise, unit of measurement for length or breadth is taken as meter or centimeter. Okay, if we find the value of area, we need to write it as meter square or centimeter square. Or else if we find the value of perimeter or semi-perimeter, we need to write the value as meter and centimeter according based on the problem. For example, here you can see here also. For example, we found out the perimeter here. So here written the unit as meter, and again here also if we written meter because it is semi perimeter here, and here we found out the area, that is ET meter square. Here we have written meter square because it is area. So this is also very important because you may lose some marks just for writing the units also. So keep in mind it. Okay. Okay, let us move on to the next part. So in this part, let us find out the sum of the uh, let us find out some areas of some triangles. Triangles such as right angle triangle, equilateral triangle, and isosceles triangle. To begin with, let us find out the area of the right angle triangle. So I have taken a right angle triangle here, and let me name it as A, B, and C. As this is a right angle triangle, one angle should be of a 90 degree. So this angle is 90 degree angle, and let me take the side AB as 12 centimeter, side AC as 13 centimeter, and side BC as 5 centimeter. Okay, as you all know, the basic formula to find out the area of right angle triangle is, that is area of triangle is half into base into height. Okay, so area of triangle ABC is equal to half into, let me substitute the values here. Here base is 5 centimeter into height is 12 centimeter. Okay, let me cut it out here itself. 2 1 the 2 6 the, so 6 into 5 is 30. So again here we need to write here the unit of area, that is here we taken centimeter, so it is centimeter square. Okay, let us move on to next part. So here let us try to find out the area of a equilateral triangle. So before proceeding, let us know what is equilateral triangle. So equilateral triangle, as the name says, all sides should be of equal length. Means here it is 10 centimeter. So here also it should be 10 centimeter. Here also it should be 10 centimeter. Means in equilateral triangle, all sides will be equal. So I have taken triangle PQR to explain you. So let us write the basic formula to find out the area. Basic formula, as you all know, it is half into base into height. So if you want to substitute the values here, half okay, and base is 10 centimeter, that is also okay. But height, they have not provided height here. So we need to create height here. So in order to substitute the value of height here, we need to create height. How to create height? Observe here. So I will take the midpoint of QR as M. Okay. As I mentioned midpoint, so this whole length of QR is 10 centimeter. As it is midpoint, so this M divides QR into half. Okay, so this QM becomes 5 centimeter. Likewise, this MR also becomes 5 centimeter. So let us draw a perpendicular line, that is perpendicular line from P to M. Okay, as I mentioned perpendicular, so this PM, the line PM is perpendicular to QR. So as this line is perpendicular, it makes a 90 degree angle here. Okay, our aim is to find here, our aim is to find the height here. So means we need to find the value of PM. So in order to find value of PM, Pythagoras theorem helps us. Okay, Pythagoras theorem. Pythagoras theorem. Pythagoras theorem helps us. So what is Pythagoras theorem? Pythagoras theorem means the side that is opposite to 90-degree angle is means the side opposite to 90-degree angle is hypotenuse. So Pythagoras theorem says hypotenuse square will be equal to means PQ square will be equal to sum of the squares of other two sides, means it will be equal to PM square plus this side PM square plus QM square, means Pythagoras theorem says hypotenuse square will be equal to sum of the squares of other two sides. So here hypotenuse is PQ, its square will be equal to the sum of the squares of other two sides. So one side is PM square plus other side is QM square. Okay, let us substitute the values here. PQ square, so PQ is 10 centimeter, that is 10 square is equal to PM. So we don't know the value. This is what we need to find. So let me write it as it is, PM square plus QM square. QM square is 5 square. Okay, so 10 square is 100 equal to PM square plus 25. So PM square will be equal to 100 minus 25, that is PM square will be equal to 75. Let us move this square to this side, means RHS side. So PM will be equal to square root of 75. We can write this 75 as 25 into 3 also. Okay, so PM equal to square root of 25. You know 5 5 is 25, so square root of 25 will be 5 inside root 3, means we are able to find out the value of PM, this value of PM. So value of PM came out as 5 root 3, and again unit is centimeter. So we find the value of PM as 5 root 3. Means here we found out the height here. Now we have all the values here, means area of a triangle will be equal to half into base into height. Now we have the area of now we have the value of base also and height also. So now let us substitute these values in this formula. Okay, half into base is 10 centimeter. Why is 10 centimeter? Because we are finding the area of triangle PQR. Now we are taking this whole triangle, but in Pythagoras theorem we just took this PMQ triangle, but here we need to take this whole triangle. So I write this base value as 10 centimeter and not 5 centimeter. Keep it in mind. And we height means PM. The value came out as 5 root 3. Let me substitute this here also. 5 root 3. Okay. So let me cut out here also. Here only 2 ones are 2 5s are. So the value came out as 25. 5 into 5, 25 root 3. Okay, 5 into 5 is 25, and this inside 3 will be inside root only, 5 root 3, and again the here unit will be centimeter square, because we are finding area here. Okay, area of triangle PQR will be 25 root 3. Okay, but in order to here, one thing you need to observe is here we didn't know height here. So in order to find height, we took the help of Pythagoras theorem. So if you don't know height, we need to take the help of Pythagoras theorem. Okay, if we need to apply Pythagoras theorem, we need to create a right angle, because Pythagoras theorem holds good only to right angle triangles. Okay, if you can observe here, by drawing perpendicular line PM to QR, we have created a 90-degree angle. That is, we have created a right angle triangle here, because Pythagoras theorem holds good only for right angle triangles. Okay. By applying Pythagoras theorem, we are able to find its height. By first we need to find the height by using Pythagoras theorem. Then again come to this basic formula and substitute the value of height and get the answer. This is how we find the area of equilateral triangle. Okay, let us move on to the next part. Here, let us try to find the area of a isosceles triangle. So, what is isosceles triangle? Isosceles triangle means any two sides will be equal in a triangle. As you know, triangle consists of three sides. Okay, here two sides will be equal and another side will be different from other two sides. As you can see here, this side is also 5 centimeter and this side is also 5 centimeter. So these two sides are equal, but this side is 8 centimeter. So this is a isosceles triangle. So let me name it first. This side as X, it as Y, and again this one as Z. So again here also let us find the area by using the basic formula, that is half into base into height. Okay, so again we know we have half here, and again we have base as 8 centimeter. Again we don't know height here, so here also we know, like equilateral triangle, here also we need to create height. So in order to create height, I will take midpoint P. It is midpoint of YZ as P. As I mentioned, midpoint. So this point P bisects the line or side YZ into two equal parts. So if the value of this whole YZ is 8 centimeter, this then the value of YP came out will be half of 8 centimeter, that is 4 centimeter. Likewise, PZ will be 4 centimeter. Okay. Here also we need to find the value of height XP. Okay, height XP. So we need to find this value of height. So in order to find the value of this XP, we need to take the help of Pythagoras theorem. Okay, Pythagoras theorem. So what Pythagoras theorem says, hypotenuse square will be equal to sum of the squares of other two sides. Side 1, let me take this side 1 and side 2 square. Okay, here hypotenuse means, as you know, here we have created a perpendicular line to YZ. So as it is a perpendicular line, it creates a 90-degree angle. Okay. Hypotenuse, here Pythagoras theorem says hypotenuse square will be equal to sum of the squares of other two sides. So here hypotenuse will be xy. Why xy? Because always hypotenuse will be opposite to 90-degree angle. So here it is 90-degree here. So the opposite side will be xy. Xy square is equal to sum of the other two squares of sides. Okay, here one side is xp square plus another side is yp square. Okay, let me substitute the values here. Xy square is 5 centimeter square equal to xp. We don't know that is what we need to find out now. Let me write it as it is, xp square plus yp square. Yp is 4 centimeter, that is 4 square, that is 4 square. Okay, 5 square is 25 equal to xp square plus 16. Okay, so xp square will be equal to 25 minus 16. Okay, xp square again will be equal to 9. So in next step, let us take this 2 to RHS, hence it will become, here it is square, if you move this square to RHS side, it will become square root of 9. As you all know, 3 into 3 is 9, so square root of 9 is 3 centimeter. Remember, here unit is 3 centimeter because we have found out the height here or length. Okay, so the value of height came out as 3 centimeter. Here xp is 3 centimeter. So again come to this basic formula of finding area. So area of triangle XYZ will be equal to half into base is 8 centimeter. Remember, why 8 centimeter? Because now I am taking this whole triangle. Okay, 8 centimeter. We should not keep this value as 4 centimeter because now we are finding the area of a whole triangle. But by when we are using Pythagoras theorem, we just took this right angle triangle x, y, p. That's why we have written this. We took there where it is. We took 4 here, but now we are finding the area of this whole triangle. That's why we need to write the base as 8 centimeter. Then height as, here we have found out this 3 centimeter. Xp is 3 centimeter. Okay, let us cross cut here itself. 2 1s are 2 4s are 4 into 3 12 centimeter square, because the unit of measurement of area is 12 centimeter square. Okay, till now we have found out the areas of right angle triangle, equilateral triangle and also isosceles triangle. If you observe keenly here, in order to find area by using this formula, that is the basic formula half into base into height, we need the value of height. Okay, we wanted the value of height of a triangle. So in order to find height, we took the help of Pythagoras theorem. Okay, in order to apply again Pythagoras theorem, the basic requirement of applying the basic requirement for Pythagoras theorem is the triangle must be of 90-degree angle. Means to apply Pythagoras theorem, the triangle should be a right angle triangle. Okay, if you observe here, by drawing a perpendicular line, we have created a right angle triangle here. Likewise, I will take this one as example also. In equilateral triangle also, we have created a right angle triangle, that is 90-degree angle, by drawing perpendicular line PM. Why we have created 90-degree angle? Because here we, in order to find height, we need to take the help of Pythagoras theorem. Okay, but Pythagoras theorem holds good only for right angle triangles. So in order to create a right angle, we have drawn the perpendicular here. Okay, as you all know, Pythagoras theorem holds good only for right angle triangles. Okay, if you have doubt, I will give one example, that is to show Pythagoras theorem does not hold good for right angle triangles. Okay, let me take one example here as a scalene triangle. Okay, scalene triangle means all sides will be of different length. As you can see, side AC is 4 centimeter here. Okay, side BC is 3 centimeter. Okay, and side AB is 2 centimeter. Okay, in order to apply Pythagoras theorem, we need to create a height here. Okay, so but we don't know any clue to find the height here. We don't know height, but let us blindly apply Pythagoras theorem here. So Pythagoras theorem says hypotenuse square will be equal to sum of the squares of other two sides, side 1 plus side 2. Okay, so here hypotenuse square, let us take AC as hypotenuse, because always the length of hypotenuse will be greater than the other two sides. So here greater value is 4 centimeter. So let me take hypotenuse as AC. Okay, AC square equal to one side I will take it at BC, and again another side I will take it as AB. Let me substitute the values here. AC is 4 square plus BC is 3 centimeter square plus AB is 2 centimeter. Okay, 4 square is 16, 3 square is 9 plus 2 square is 4. So 16 equal to 13. That is not true. So 16 is not equal to 13. Okay, by this, I hope by this example you came to know that Pythagoras theorem holds good only for right angle triangle. As you can see, this is not a right angle triangle. So if you in exam if they have given a scalene triangle and they say that find the area of this triangle, but here you can't apply basic formula. Okay, you can't apply basic formula, that is half into base into height, because though we have value of base here, we don't know the value of height. So if we don't know the value of height, we can't apply the basic formula, that is half into base into height. So that is where the Heron's formula, what? Heron's formula, that is where Heron's formula helps us. If we don't know the value of height, then we can apply this Heron's formula to find out the areas of such triangles, such as scalene triangle. But it doesn't mean that we can't find the areas of right angle triangle, equilateral triangle, isosceles triangle by using this Heron's formula. No, not like that. This Heron's, by using Heron's formula, we can find areas of any triangle, be it right angle, be it equilateral, be it isosceles triangle, be it acute triangle, be it any triangle. By using Heron's formula, we can find the area of any, triangle. So in order to make you understand the need of Heron's formula, I have explained you the areas of finding areas of isosceles triangle, equilateral triangle, and also the right angle triangle. So in next class I will explain how to find the area of a triangle if we don't know the height of any triangle. Means by using Heron's formula we can find the area of triangle if we don't know the value of height also. Okay, till now this was the introduction class to Heron's formula. In next class I will explain what is the Heron's formula and also its application in finding the areas of any triangle. I hope until now, up to now, you are very much clear about the basics. So if you find any difficulty in understanding this class, means if you have any doubts, please write it down in the comment section. I will answer all of your questions, and if you like this class, or if you are able to understand the basics of this class, please hit a like button and subscribe. Thank you.